I want to talk about the three things that can arise from the law of sines ambiguous case. There are three possible scenarios when we use law of sines and we are given a side-side angle situation. And just as a reminder from geometry, this is not a congruence proof. This is not a way if two triangles have the same two sides and a not included angle, that does not prove those triangles are congruent because we can actually draw two triangles that would fulfill that. The most common one is something like this, where we might say these two sides are the same, these two sides are the same, and this angle's the same. But you see, I can draw two completely different triangles that fulfill that. So we always have to be careful when this is the scenario. And I'm going to go through the three possible things that can happen with law of sines when we're solving. And I'll explain with my picture what has happened. Okay, so let's start with this setup. Let's say I'm trying to solve for x. So using the law of sines, we can see right away we have this relationship that we have the side and angle across from it. So we would say the sine of 70 over 15 is equal to the sine of x over 97. I'm going to cross multiply. 97 multiplied by the sine of 70 is equal to 15 multiplied by the sine of x. Divide both sides by 15. And of course, if I want to get x by itself, I will take the inverse sine of both sides. So it's just x equals. Let's see what happens. So we're going to take the inverse sine of 97 multiplied by the sine of 70, all divided by 15, and we get a non-real answer. And the reason is the thing I'm trying to evaluate, the 97 times the sine of 70 divided by 15, is larger than 1. I'm trying to find the inverse sine of something that's not actually in the domain of inverse sine. So here's what happened right there, is the side lengths were such that this is an impossibility. And what essentially that means is that this side right here is not long enough for this triangle. So imagine I gave you a setup and I said, like, here is what the triangle begins to look like, and the third side is only that long. You'd say, well, I can't make a closed triangle if that side is only that long. That's what happened here. 15 wasn't long enough to make a real triangle. Now, if the other side was 97 and this was 70 degrees, I create a non-closed up shape. It's not even a real geometric shape. So this is an easier one to spot because you literally get to the end after doing your calculations and you're like, oh, it wasn't even possible. I ended up with a side length that was too short to even make a triangle. Let's look at a different scenario. All right, let's set up our law of sines using our relationship again that are established as sine of 84 over 800 is equal to the sine of x over 670. Cross multiply. Divide both sides by 800. Take the inverse sine of both sides. And let's type this in. All right, inverse sine of 670 times the sine of 84, all divided by 800. 56.4 degrees. So 56.4 degrees. Now, here's what we need to check for. we need to check that case where that third side could do this or this. And the relationship between those angles would be that they would be supplements of one another. Meaning, we're going to check, okay, we think this could be 56, or it could be the other half of the other part of 56 that adds up to 180. So we always check, we say, okay, in that scenario where we can make two triangles, the other possible angle would be 180 minus 56.4, which is 123.6. So we have this angle or this angle. And you might say, okay, so we found those two possible triangles because we have two. But here's the issue. We knew 84 degrees. And we said this could either be 56.4 or 123.6. But if you were to add up 56.4 and 84 degrees, you would get something that is less than 180, meaning there is some leftover angle to go down here. We got some more degrees to work with. This makes a triangle. This one works. But if we were to do 123.6 plus 84, again, the one we knew, that's bigger than 180, meaning we have broken the triangle angles. We've got too many degrees. We've got nothing left to create a closed shape. So this is not a solution. Now, what did we just find? What kind of triangle would fulfill this? Or would this look like? And it would be this. Essentially, it's creating a triangle that looks like this, where this is the side in question, and its length, if you were trying to like swing it over this way to do that kind of two triangle possibility, would end up going beyond the bottom and would make a triangle, but also have like leftover piece at the bottom. So that side's too long. It can't actually make a just simple, nice closed triangle. So that is the other possibility. So what you should do just all the time, if you get to the end with an answer, is figure out the supplement, do 180 minus, see it could be either one of these, and then add it to the angle you know, and verify that it was less than 180. So this angle that we weren't even worried about actually could possibly exist. So here, again, this adds up to something where we could figure out, yeah, we know what this is actually, but this is over 180, so it doesn't work. It's this thing right here. All right, let's do one more. All right, let's establish our law of sines relationship. Sine of 54 over 4.9 equals sine of x over 6. Cross multiply. Divide both sides by 4.9. Take the inverse sine of both sides. I'm just going to type that in on my own quick. And I get that the angle is 82.2. But let's check the other. Remember, there could be two triangles, so 180 minus 82.2 is 97.8. So it could be this one or this one. Here's how we verify. We go to the angle that we know, and we say 54 plus 82.2 and 54 plus 97.8. And guess what? Both of these are less than 180 degrees. So both of them work. So when we say, well, what's the answer? It's both. It's 82.2 degrees or it's 97.8 degrees. And again, from a picture standpoint, this is the most famous thing we have to watch out for, and that is that there could be two side lengths the same size that fulfill what we did. So again, with law of sines, the first thing to look for is just a problem is two sides and an angle that wasn't included between them. If we have two sides and the angle is included in those sides, for instance, in this example, 4.9 and 6, if the angle that we had was this angle, that would be workable. We could just proceed without any worry. But it's the fact that we have two sides and the angle is not, the given angle isn't between them. One possibility is there are no possible triangles. Essentially, the height of the triangle is larger than the opposite side, and you'll just get an error. Okay. Another possibility is one possible triangle, meaning one of the sides is so long it can't possibly, almost like this one, hinge. It would hinge over and go beyond the bottom of the triangle, and you'll know that by doing our check. You'll get your number, figure out the complement of the angle, and then you will check with the given. You'll say, okay, I was given this. If I added the two possible scenarios, do I come in less than 180? And meaning I still have some angle left for this. And if only one of them works, then you had one possible triangle. Two possible triangles means you have those two numbers, and they both, when added to the known angle, return less than 180. So it's a lot of work, law of sines, to verify everything. Or it's a lot to think about when you have this scenario. If this video helped you, please like and subscribe for more math help.